All right, homogeneous type of trigonometric equation. Couple pointers here. First, the degree of each term must be the same. So as you may notice that we have sine squared, we have cosine squared, we have sine x cos x. So this is the degree of each term is 1, but when you're multiplying them, it becomes 2. And the constant, we can change the degree of that using Pythagorean identity. So 2 times 1 is 2, and our 1 is expressed as the sum of sine squared plus cos squared. So first, change that constant using Pythagorean identity, and now we have entire equation with where each term has same degree. Okay, so what you're going to do now, we will expand it, just the right hand side, but before we do that, we can sort of foresee the next step that will be dividing each term by cosine squared x. So I'm gonna show this by going like so. So cosine squared x, this term divided by cos squared x, one here, and cos squared x. And also you must be aware of that we can split this, so it's going to be sine over cosine and cos over cosine. Excellent. So what will be the result of that? 3 tangent squared x. Remember, sine over cosine ratio is equivalent to tangent. So when you have squared, so that is tangent squared. Over here, cosine and cosine will be reduced, and you will have 4 times sine over cosine, so that is 4 tan x. Over here, cos squared over cos squared, so this is 5. And then sine squared over cosine squared, so minus 2 tangent squared x. Once again, sine squared over cos squared, tangent times 2. And then cosine over cosine is 1, so bring over to the other side, so minus 2 equals 0. Okay, now, so combining like terms, tan squared, okay, that's one group, and then we have 5 and negative 2. So that in total we will have tan squared x plus 4 tan plus 3 equals 0. So what happened? We have been able to reduce this equation into quadratic type of equation with one function, one angle. So this is an excellent stage. Actually, I like this stage right here, so that's a happy face for that. And we can do this quadratic equation now because we know what to do. So we'll assign new variable, let y be tan x. So quickly we have y squared plus 4y plus 3 is equal to 0. Alright, can we factor it? I think we can. So this is y plus 1. If factoring is not feasible, remember, always use quadratic formula. So you just quickly look at the equation, can do factoring right away, don't feel bad, the quadratic formula. So y plus 3 is equal to 0. So this will give us, converting to a tangent, so tan x is equal to -1, or tan x is equal to -3. So -1 is a nice case where x is equal to first -1. So we call pass through second quadrant. Okay, so this is 3/4 pi. And then the fourth quadrant, so by adding pi, you get 7/4 pi. But when you want to finish off with a general statement, we can do minus pi/4 plus k pi. Just think for a second. If k is 1, then you have pi plus -pi/4, which will give you 3/4 pi. So this is a nice way of starting with the simplest form. When you start with the very basic statement for the root of equation, and by adding multiples of pi, and k is any integer, so you may have positive or negative value, including 0. Okay, in case of this root, x will be expressed as inverse tangent, so tan -3 plus k pi. Okay, so this is the solution. Okay, x and x here. So always verify. So select randomly value of k, plug it into original equation, and see if you can balance it. Okay, so the key here was to make the following observation. The degree is consistently the same for all terms. A constant can be converted into a second degree term by simply using Pythagorean Identity. Then you divide every single term by cos squared x, converting into tangent ratio. Simplify, use the substitution method, quadratic equation, either factoring or quadratic formula. Find a solution for the first angle, and then if you need to do general solution, then you need to be aware what is the basic period of our function. So tangent period is pi radians, so this is why we add multiples of pi. If you were given the interval, then you always will find all those roots that would fit into the interval. I hope that helps. Thank you for watching this video, and I see you next time.